Hi students, today we are going to derive the equations of kinematics, which are otherwise called as equations of uniformly accelerated motion by calculus method, that is integration method. Now you must have already derived the equations and knowing the three equations. The first equation is called as what? Velocity time relation, that is v equal to u plus at. And the second equation is called displacement versus time relation, that is given by s equal to ut plus half at square. And the third equation is velocity displacement relation, that is v square equal to u square plus 2as. So that we are going to derive by integration method. So before deriving these equations, let us assume that the initial velocity of the body at the time t equal to 0 is represented by small u, and the final velocity after a time t is represented by small v, and let a be the uniform acceleration, which is a constant. So I can also represent a as a constant acceleration. Now first we will derive velocity versus time relation. So for that, from the definition of acceleration, so from definition of acceleration, how will you define acceleration? It is a rate of change of velocity. So a is equal to dv divided by dt. So this equation implies dv is equal to a into dt. So dv is the variation in the velocity and dt is the variation in time. So this velocity of a body changes from initial value u to a final value v, from a time t equal to 0 to a later time t. So I am going to integrate this equation dv equal to a into dt between the limits. So integration, okay, on integration, the above equation is integrated. So left side will become integral of dv. The right side, a acceleration is constant, we cannot integrate. So I will leave this outside the integral, into integral of dt. So the velocity changes from initial value u to a final value v. So what is the lower limit of the integral? That is u, and the upper limit of the integral on the left hand side is v. Similarly, the time lower limit is 0, the upper limit is t seconds. So this is the integral on both sides. Now this is integral of u to v. Now dv, so this is what? V power 0 into dv. So this is equal to acceleration a into t power 0 into dt between the limits 0 to t. So it is 1 into dv on the left hand side and 1 into dt on the right hand side. So we must remember the standard integral. The standard integral, namely integral x power n into dx is equal to x power n plus 1 divided by n plus 1. So this integration has to be applied here, so that left hand side velocity is raised to the power 0. Is it not? So x power n, here n is equal to 0. N, in place of n we have written 0. So that the value of the integral will become v power 0 plus 1. V power 0 plus 1 is what? V itself. Divided by 0 plus 1 is also what? 1 itself. So the integral will become v. So the left hand side is v from u to v. So this is equal to a into, this is t power 0 plus 1 divided by 0 plus 1. So this is t by 1 is equal to t. Okay, so this is between 0 to t. Now, the left hand side, the value of the integral is what? The upper limit minus lower limit. So, upper limit minus lower limit must be equal to a into upper limit minus lower limit. So that v minus u is equal to a into t, or I can write this as what? V equal to u plus at. So this is the first equation. So the velocity versus time relation is given by v equal to u plus at. Okay. Now the second equation is what? Displacement versus time. Okay. Displacement time relation. So for the second equation, namely displacement versus time relation, we start from the definition of velocity. Here we started from the definition of acceleration, is it not? So here from definition of velocity. So how do we define velocity? Velocity is defined as the rate of displacement, is it not? So v is equal to ds by dt, and this implies ds is equal to v into dt. Okay, so ds is equal to v into dt. But from equation 1, in place of v, what we can write? U plus at. In place of v, we can substitute u plus at. So I can also write this as ds. So ds is equal to, instead of this, u plus at, okay, into dt. Or I can split the right hand side into two factors. ds is equal to u dt plus at into dt. This is the next equation required. I am going to integrate this equation on both sides. So on integration on both sides between the given limits. So on integration, left hand side will become what? Integral ds, and the right side is u dt. U means what? It is the initial velocity at a time t equal to 0, which is a constant. So I will take this out of the integral into dt, plus a is the acceleration also is constant. So a into integral t dt, integral t dt. So this is 0 to s, and here 0 to t, 0 to t. So integral of ds is equal to what? S itself. So the left hand side, the value of the integral is s, from 0 to s. So this is equal to u into integral of dt is t, between 0 to t, plus a into integral of t dt is t power 1 plus 1 divided by 1 plus 1, that is t square by 2. So this is t square by 2 between the limits 0 and t. So left side upper limit minus lower limit is s minus 0. This is equal to u into upper limit minus lower limit, that is t minus 0, plus here a by 2 is there, is it not? So this is a by 2 into t square minus 0. T square minus 0. So s minus 0 is what? S minus 0 is equal to s, equal to u into t minus 0 is u into t, plus a by 2 into t square is nothing but half a t square. So this is equation 2. Okay, so the second equation, namely the displacement versus time relation, is given by s equal to ut plus half a t square. So what is the third relation? The third relation is velocity displacement relation. We are going to derive the third equation, namely v square equal to u square plus 2as. So I am going to derive this by rubbing this side. I think up to this, have you all noted down? Have you all understood? Okay. Now we are going to derive the third relation, namely velocity displacement relation. So for this, once again, from the definition of acceleration. So from the definition of acceleration, what is A equal to? Acceleration is the rate of change of velocity. So I will take A is equal to dv by dt. Now I will multiply the numerator and the denominator by the change in the displacement ds. So this is a dv by ds into ds divided by dt. Okay, I have multiplied by ds and divided by ds so that the value does not change. So this ds by dt is rate of change of displacement, that is equal to velocity. But this ds by dt, ds by dt is equal to v, so that is equal to velocity. Therefore, the above equation can be written as A is equal to dv by ds into v, or A into ds. Okay, A into ds can be written as v into dv, v into dv. Understand that? So now we can also write this in the integration form. I am going to write this in the integration form, or I can write ds is also equal to 1 by a into v dv. Before integrating, I am changing like this, then I am going to integrate. Okay, so I am integrating this equation. On integration, left side becomes the integral of ds, right side becomes 1 by a into integral of v into dv. So the left hand side integral, the lower limit is 0, upper limit is s. Displacement varies from 0 to a maximum value s, whereas the velocity changes from initial value u to a final value v. So on integration, the left hand side will become integral ds. Integral ds will be equal to s between the limits 0 and s. The right side is 1 by a into integral of v dv is v square by 2. But the value of velocity, okay, the value of velocity changes from initial value to a final value v. So the upper limit minus lower limit on the left hand side will make it s minus 0. So this is equal to 2 is a constant, I will take it out. So it will become 1 by 2a into upper limit for v square is v square itself, minus lower limit for v square is u square. So s minus 0 is s. So s is equal to 1 by 2a into v square minus u square, or 2as is equal to v square minus u square, or v square is equal to u square plus 2as. So this is the required equation number 3, which is called as velocity displacement relation. Okay, students. So v square equal to u square plus 2as. Now one more equation, okay, that is also called as the fourth equation we can state. So for that I am going to derive the fourth equation also. Okay, that is displacement s is equal to u plus v by 2, the average velocity into time. This equation can be considered as the fourth equation of kinematics. I am going to derive this also for solving the numerical problems. So for this, I am going to consider V equal to U plus AT, or AT is equal to V minus U. So this is one step. So instead of AT, I can substitute V minus U. Then we know that another equation is S equal to UT plus half AT square, or S equal to U into T plus this half AT square can be written as half into AT into T. AT into T is AT square. Now this term AT is there already. In place of AT, what can I substitute now? B minus U. So we will write R S equal to UT plus half T. This T is there, half T into AT. Instead of AT, I can write V minus U. This T is written here. In place of AT, I have substituted V minus U. Then I open up the bracket. So S is now equal to U into T plus here half into V into T. So this is half into V into T minus half into U into T. Understand that? This is UT, this is minus UT by 2. UT minus half UT is what? Plus half UT. Is it not? Plus half UT. So UT minus half UT is half UT. So this is equal to half UT plus half V into T, or S is equal to 1 by 2 into U plus V into T, or S is equal to U plus V divided by 2 into T. So the four equations of kinematics we have derived. The first equation is called by the name velocity time relation. So V equal to U plus AT. The second equation is called displacement versus time. It is given by S equal to UT plus half AT square. The third equation is named as velocity displacement relation, and that is given by V square equal to U square plus 2AS. And the fourth relation is S equal to average velocity V plus U by 2 into T. I hope you must have understood all the four equations well. So practice deriving these equations again and again and put them to use in solving the numerical problems for competitive exams like the NEET and the JEE. Okay, fine.